Rambabu, sir.
Good morning. Yes, sir. Good morning, one and all present here. Today I'm Kasiti Rambabu, the coordinator of this session. So today I would like to introduce today's speaker, Sunil Kumar sir. So Sunil Kumar V has graduated as Electronics and Communication Engineer from Visvesvaraya Technological University and completed Masters in Embedded System Design from Manipal University. He started his career at Indian Institute of Sciences and has implemented numerous projects for the Ministry of Defense at DRDO Hyderabad for more than 10 years. And he has also worked as associate manager at HCL Aerospace, Bangalore, and later joined at Megit Aircraft Systems at Coventry, United Kingdom, and has worked for 2 years at NATO Defense projects. Currently, he owns VI Solutions, an autonomous company headquartered at Bangalore. The company has implemented several turnkey systems and system integration projects for various organizations of Ministry of Defense. VA Solutions System Integration Integration Practice provides end-to-end management for requirements, development to solutions, integration, and ongoing support. So his key interest areas include embedded systems, automated test equipment, data acquisition, electronic manufacturing or military production support, wire and wireless communications. So with this introduction, I will hand over the session to Mr. Sunil sir. Sunil sir, over to you, sir.
Yeah, thank you so much.
Sir, there is an echo problem with your mic, sir.
Oh,
Some
is it?
echo. Yes, sir.
Okay. Let
Slightly,
me.
slightly, sir.
Now is it fine?
Yes, sir.
Now it's better, right? Okay, nice. Okay, thank you so much. First of all, I'm just very much glad to be part of this session. So there is upcoming session also, that's going to come related to, the communication and even vision process, vision inspection systems. Keeping everything in mind, what has been completed and what is going to happen, I want to keep it simple. That is going to make some, benefit of this session. I'm basically looking out for, see, you people are just attending this session for like now 6 days, believe overall the 6 days you're just attending it. I want to like show you people how this is being used in industries and widely, because more than understanding the concept, you have to know where this has been implemented and what kind of job opportunities your students or in the future for you people, how it's going to be happening, what is the the scope which is needed, what is the industry is expecting, all these things I want to just bring it to you in this session. So quickly moving into the session, as I said, the vision of this program is going to be first of all understanding the industry. What is the industry is now currently working on, what are the technologies being working, what is Industrial Revolution 4.0. In the meanwhile, I'll be also showing you the Industrial Revolution 1.0, 2.0, 3.0, all the things. I'll just quickly bring it to you, and I'll be showing what are the recent technologies that are just trying to implement, that are being used to implement Industrial Revolution 4.0. I want to tell you people about that, right? So in which I'll be even trying to tell you about what is artificial intelligence, what is machine learning, what is deep learning, how it is being implemented using NI technology. Then when it comes to Internet of Things, how NI is providing support for Internet of Things, how it can become, how a data can be pushed and retrieved back from the cloud, and what kind of support you can get from the cloud, and what are the different types of cloud you can use. All these things I want to quickly tell you people. And moving next, I want to tell you how National Instrument is being used in automation, apart from Industrial Revolution 4.0, where you'll be understanding what is industry. First of all, I want you to understand what is currently happening in industry. And the second part, I want to show you how National Instrument is using this in industry, right? And there is a huge plan for National Instrument down, like 50 to 100 years down the lane, the entire century. They have a lot of plans. I want to just quickly discuss about like what NI is having a vision towards, industrial automation, how they are going to bring up new technologies. Forget about what is the current existing technology. They also have a plan of, about the future, like, down the century, the entire century, what kind of, technologies might evolve. See, for example, let me say Internet of Things is, it's a very, hot talk, in the recent research and even in industries. But if you see, National Instrument have been using Internet of Things right from the year of 2008. Right from the year of 2008, they have produced some hardware that basically works with WSN, wireless sensor network. Now, which is in a very bigger level, it is now considered to be an Internet of Things, which I'll be discussing to you about. So always NI, National Instrument, had a vision towards the future. Even now, if you see, they have planned for some of the verticals of the domains where they have to concentrate on. So all these things I'll be quickly telling you people. So jumping into the agenda today, today's agenda, I'm gonna keep it as 3 sections. Section number 1, it's gonna be, as I said, it is gonna be about Industrial Revolution 4.0, in other ways IR4, right? Completely starting where it started, where we are now, what is the future. All these things I'll be telling you about Industrial Revolution 4.0. This is the current trend, basically. This is the current trend when it comes to automation. So basically, I'm more towards automation because this is the future. So even though there are a lot of things, there are a lot of things, even in the previous section and even the next session, people are going to cover. But exactly speaking, automation is one thing which is going to make a future. So I want to talk more about automation. So industrial revolution, how it's going to be impacting our engineering life. I want to talk to you all about that. Then section 2, I want to tell you about Internet of Things and the artificial intelligence. Anyway, they are like subset of Industrial Revolution 4.0. See, I'll tell you one thing. When I talk about Industrial Revolution 4.0, I don't know how many of you have heard about this. When I talk about IR4, it basically about building a smart factory. It is about building a very smart factory. So when I talk about smart factory, all the the machineries inside the factory has to be a little smarter, right? Compared to the current technology what we people are using, it has to be a bit smarter. That's where artificial intelligence comes into picture, and then these smart machines should communicate with each other. That is where Internet of Things comes into picture. So ultimately, when I talk about Industrial Revolution 4.0, in other ways, talking about the smart factories, your Internet of Things and your artificial intelligence will automatically come into picture. In the section 2, I'll be talking to you all about how National Instrument is handling this artificial intelligence technique and Internet of Things. See, genuinely speaking, this artificial intelligence and even Internet of Things, they are in a very baby stage of in implementation when it comes to industry. I won't say that they have just full-fledged wise. No, nobody has done that. Not only National Instrument, nobody has done that in full-fledged. But the scope is there, the vision is there, the visionary we have. So what kind of updates that is going to come up in the future? How you people should be ready for industry, or maybe your students. I think most of them are faculties here. I don't know whether there are some students, because when I was talking to the coordinator from VA Solution about this, he was telling about this is going to be more of faculties. So I'm really glad to meet the faculties, because when I reach students, it's going to be a very limited of like 100 people or 150 people who are attending the session. But when I can address a faculty gap, a batch of faculty, they can address like thousands and thousands of people. So I'm very glad to actually address the faculties. So I want to educate the faculties about the future, and which in case in the future I want your students also to be educated from yourself. That's the reason I'm just so glad about this. And section 3, I'm going to tell you how NI is completely working in industry. First, I was just telling only about Industrial Revolution 4.0. Apart from this, overall, collectively, what NI is doing in industry, how they are going to implement their technology in all the fields. I'm going to tell you about that. Right. So if the agenda is very clear, I'll just quickly jump, and then I'll just tell you one more thing. If the time permits, my limit is, I was told my limit was 11. And anyway, I was just like 5-10 minutes late because of this technical issue. So let me say, I'm just going to 11:15. If time permits, I would like to show some demonstration of Internet of Things also, and even artificial intelligence also, where I just try to connect to the internet. Anyway, we are connected to internet now. We are just streaming this session also through internet. I want to push the data into the cloud and get it back from the cloud. How National Instrument very quickly wants to do it. So basically, these things happens in National Instrument. I think you people are working on LabVIEW right now, correct? In this entire sessions, you people would have been seeing the tool called LabVIEW. It is one of a very powerful tool when it comes to industry. I'll tell you why it is considered a very powerful tool. When it comes to industry, the very important part that keeps in that has to be kept in the mind of anybody is how quick we can do something. It is a testing, how quick I can do a testing. If it's a development, how quickly I can do a development. Right? If it is a package and distribution, how quickly I can do it, because rapidly you have to do it, because the more the amount of production you can do, the more benefits you can acquire, more updates you can give, more revenue you can generate. There's everything success when you can do things very faster. LabVIEW and National Instrument basically lets you to do that. That's why most of the industry, especially when you see the product-based industries, any of the product-based industry, one or the other way they'll be using NI technology in some part, at least a minor things where they feel like it is very critical, they will be using National Instrument technology, which I'm going to quickly tell you about everything. So now I'll just quickly jump into the section 1 where I want to show you about Industrial Revolution 4.0 in and out. As I say, it is 4.0. Obviously, the Industrial Revolution 1.0, 2.0, 3.0 is there. I'm going to quickly tell you people about what is 1.2, 1.0, 2.0, and 3.0 also. So when I talk about history of Industrial Revolution 4.0, it all starts with 1.0. Right. So when I talk about Industrial Revolution 1.0, it all started with mechanical steam powered engines. Basically when we are using a steam powered engines in a very long mechanical models, that's where Industrial Revolution 1.0 started. So basically when I talk about Industrial Revolution 1.0, it was marked at the end of 18th century, somewhere like 1760s it was started. So it was basically using steam powered mechanical engines. Okay, it was using steam powered mechanical engines, and moreover the highlight of this, or the successful product what human beings were able to provide, is the steam engines. The steam locomotive trains, what we people know, steam engine trains we produced. Then going back to 2.0, it is an upgrade of 1.0. Everything is in that way. 4.0 is upgrade of 3.0. 3.0 is upgrade of upgrade of 2.0. In that way, 2.0 was used in complete manufacturing sector where there was huge amount of mass production was involved, right? So when I talk about mass production, the assembly lines, the basically the conveyor belt type of production where the samples will be put into the conveyor belt. This was basically started exactly started for slaughterhouses. When I talk about slaughterhouses in Europe, basically in Europe, when they want to use this meat, they want to do the process of the meat. So what they were doing is, it's a mass production they were trying to do. So in that case, they were just going for the assembly lines where all the testing, all the products and everything will be tested. So from there, it was taken further by Henry Ford to the automobile industry, where they were able to bring it. Electrical trains were able to be brought up. That's what Industrial 2.0 was giving us, and 3.0 was upgrade of 2.0, as I said. So where you can see that complete automated systems were able to be designed. So usually this is basically used mostly in aircraft design. Automobile designs, where you can see that more than human beings being used to handle all the products, they were also using the machines. Complete machines were used. So ultimately, what was happening is, we were trying to bring computers into picture. We are trying to use memory programmable computers, controlled computers. So the highlight of this is we were able to do all the process, in and out process, without the intervention of human being. A robot was able to carry out all the task, right? A robot was able to carry out all the tasks, but I'm not sure if I have a video. I want to play a video because I had a video of showing how this mass productions can happen without a human intervention. I'll just show you after finishing this. I'll just quickly show you that also. Now going back to the next, 4.0 was upgrade of 3.0, right? Already you can ask me, see, Industrial Revolution 3.0 already has everything, because that it's completely automated. We were able to do all the tasks without a human intervention. So then why you need Industrial Revolution 4.0? That was a big question. Most of the people were not actually ready to take Industrial Revolution 4.0. I'll tell you why industries were not ready to take 4.0 was at the beginning. Coming back from 2.0, for example, coming back from 2.0 moving to 3.0, there was a lot of investment, because completely we were just converting the employees from human beings into machines, right? So now it's a lot of investment involved. So after a lot of, and it was like Industrial Revolution 3.0 happened exactly at 1976, like 30-40 years before, right? And down the lane, like around in the year of 2000, 2005, in approximately that age, mostly people were able to bring out a complete automated system. Exactly, complete automated system, starting from the screw to nut to bolt, complete to the painting of the car. Everything was automated, right? So now they have invested huge amount, and it's a successful outcome also when it comes to industry, because the labor charge was less, and they were able to access the industry production for 24/7. Because when it's a human being, you have to look out for shifts. A lot of shifts. I mean, there will be at least 3 shifts usually. So when I use machines, right, I don't want to think about shift. I have to make sure that the engine will have a proper maintenance. Once the maintenance is happening once in a month or once in 3 weeks, then I can just simply use the machines as much as I want, right? So a lot of investment was involved when it comes to Industry Revolution 3.0. Very quickly after 2005, immediately people started working on 4.0. That's why I was telling, even in 2008, I mean, National Instrument was coming up with the Internet of Things, right? So most of the development side industries were starting to work on Industry Revolution 4.0, which people were not recognizing as a best idea because of the lot of investment happening in 3.0. But what is happening in 4.0, I'll just tell you. So 1.0 was steam and water power, and then 2.0 was like mass production with assembly lines, electricity, steel was coming to picture. Then 3.0 was all automated software and electronics based, robots which were used. And coming to 4.0 was cyber physical system. So what is cyber physical system? I'm going to quickly tell you about cyber physical system. As I told you, 3.0 was all machines that were trying to do the entire task of production. 4.0 was adding two things to this 3.0. Number one is adding artificial intelligence to it. Number one, adding artificial intelligence to all these missions. So it knows what to do, when to do, depending upon the sample it is producing. So in one assembly line, you can't expect only one type of product. Basically now what happens is, for one assembly line, we use only same type of product and same machines will be handled. One specific type of machines will be doing. For example, let me say I'm producing a pencil, right? I have to use a machine that works with a pencil only. Right now, let me say I want to quickly bring a cell phone into picture. I want to just manufacture a cell phone. I can't use the same assembly line because I have to switch the complete assembly line. I have to change the complete the machines also, right? So this they don't want to do it. Rather, they want a simple machine, one simple machine that can analyze what product is available on the assembly line and act accordingly and do the process accordingly, right? These kind of applications needs artificial intelligence. And apart from artificial intelligence, they need IoT. IoT is nothing but Internet of Things, where machines used to communicate with each other, like how we people communicate with each other, human beings or living things communicate with each other. Same as such, the machines have to communicate with each other. You might ask why it has to communicate with each other. It makes your life faster. I'll tell you. So let me say my aim is to paint, what do you say? Like, let me say I have a wood piece. I want to paint a wood piece. Okay. So if, let me say, first level of process is happening in one machine, the painting is happening in one machine, second machine is drying it up, third machine is testing it, right? Now, let me say, if these machines communicate with each other, for example, let me say, the painting machine communicates with the drying machine. In that case, what happens is, how much amount of time is needed to be dried, because what type of chemical is being used, how much it has to be dried, what is the temperature it has to maintain. All this information will be communicated. Right, so the dryer will dry the wood piece only for the required amount of time, not more, not less. And when they communicate with each other, I don't want the third process. I don't want the testing at all, because this is a communicated process, a closed loop system where how much it has to be dried, how much is painted, what type of quality paint is being painted, and for this type of painting, what kind of dryer is needed, how much degree is needed, how much time it has to be there, everything is known. So in this case, I don't want the testing at all, where 3 level of process is now made into 2 level of process. That's the reason why machines have to communicate, right? So what is Industrial Revolution 4.0? Very precisely talking, we are currently moving into Industrial Revolution 4.0, and we have not full-fledged got the impact of Industrial Revolution 4.0. We are not completely into it. But one thing is for sure, we are trying to expand the 3.0 by communicating the machines through network, right? So if you see the third point, I'll just clearly mention, I want you people to see that. That's the reason I just made into bold. So this enables device to communicate and then share the information about themselves to the other machines. So this makes it more productive. And basically you can see that this entire 4.0 is characterized by the application of information and communication, right? So you can see that communication has come, it's a very important part. And basically this type of applications or this type of industry that uses basically called as smart factories. I repeat it, the factories that implements Industrial Revolution 4.0, they have the standards of 4.0 basically. Okay, if any factory has to undergo 4.0, they have to fulfill all those standards, right? So if a factory can do that, that will be considered as a smart factory. So basically, what does a smart factory has? It don't have normal missions. It have cyber physical system to do all the, the factory works. Right. I want to quickly show a video to you people. So this is a video where it shows how a smart factory will look like. I want to quickly check whether my audio is a full strength. I'll just quickly increase the volume if needed. I'll just increase the volume to the utmost. All right. So this is going to be a demo of how smart factory will look like, which means that a factory that uses Industrial Revolution 4.0. And it was demonstrated by TEDx. I hope you people know TEDx. It's one of a very famous company. It's loading. Oh, it crashed. Just a minute. I have the video. I'll just play the video. That is also okay for me. It is crashing. Just give me a minute. I'll just open the video. Yeah. What I'll do is I'll open the video exactly, which I want to show you, because it crashed the PPT. It was a bit good quality and high resolution video, which I want to show you. Maybe that's why it crashed. Let me quickly open it. It is resetting the system. Yeah. Oh, this is the video. Yes, it is playing. Yeah, I'll just increase the volume also. It's audible, am I right? Okay. You people can hear it?
No, sir.
Not really? Okay. Just a minute. Let me check why this is not giving any sound. Okay. I don't know. There's some issue with this volume. Okay, I'll tell you what they're trying to do. The more or less the same, demo which I was trying to tell you all about. Where, let me say, they have an application of painting a wood piece. Now let me say, what happens is there are three levels. There are three levels. One is painting level. One is oven which dries it, and then it's going to be inspection system. There are three levels. Let me say, right? So now, hello. Can you people just mute it? Yeah, thank you. So, so there are three levels. When it comes to smart factory, as I said, what happens is the first process of painting process. The first painting process will share the information to the second process of the oven, where it says what type of material it is being using for painting, what is the size and length of the object which is being painted, and how much thickness of level, how much thickness of paint is being painted. It will be just sharing all those information to the oven, right? So the oven, what it does is, understanding this information, it knows now how much time is minimum required. Basically, that's very important. Minimum required to keep this, this wooden piece to be dried. It will be knowing it. And when these two things, communicates and works in a better manner, you don't want to spend one more process of testing or, validating. Anyway, validating will be there before the, the package, there is a validation, but during the testing process, you don't need a validation, right? And even that, the validation is needed for the machines, not the products. You have to validate whether the machine is working in a proper condition or not. If you know that the machine is working in a proper condition, you don't have to test the samples, because testing the sample is a very tedious process. Because in one day in the production sector, there will be millions of products will be designed and produced, right? So it's good to test the machines rather than testing the samples, right? So by doing this, that's why the smart factory stands out. What I'll do is I'll quickly come back to the. And I'm sorry about that. There was no audio. That video, I don't know. That's a usual video I play, and it works fine. I'm just launching the PowerPoint again because it crashed. Yeah. So I'll close these things. I'll come back to the slide. I'll just quickly move to the current slide. Yeah. Now coming back to understanding how to build a cyber physical system, because I was telling you, Industrial Revolution 4.0 is all about designing a cyber physical system or using a cyber physical system in your entire industry. That's what it's now all about, your Industrial Revolution 4.0. To design it, to build a cyber physical system, what do you need? These are three things basically is needed. Number one, flexible automation and robotics. Yes, very flexible automation and robotics is needed. Connectivity between the cyber physical systems, which means the connectivity between the missions that is needed. As I told you, why they have to communicate. I was telling you to make your production far efficient to that. And then third one is intelligence, adding intelligence to this cyber physical system, right? This is how you have to design it. NI is basically involved in designing all these three. They know this is the future. So ultimately, if you see what is NI is doing in the upcoming times or down the lane, like 10-15 years, right? What they are very much concentrated is design the entire smart factory, or design, in other ways I can say, designing a cyber physical system using complete NI solution. They don't want to take any support from any other domains, because there are some, for example, let me say if NI is a automation company, it's a leading automation company. There are some other companies which are leading in connectivity. When I talk about connectivity, it can be like Cisco, Siemens, where they try to provide all the network supports, right? They are very good. So now NI wants to make sure that they are good in these things also. Basically, they want to have a tie-up with these companies, so they will bring up some products that is going to support NI for this, right? And talking about 2 and 3, which I'm going to address now. 2 and 3 I'll address. I mean, connectivity is nothing but the Internet of Things, and artificial intelligence is number 0.3. Talking about the flexible automation and robotics, NI has been doing this for many years. Starting from the day they are into the market, they have been doing this a lot. What are they doing? Providing robotics, providing the flexible automation. They have provided a lot of hardware, and this is their strength. Providing flexible automation is basically their strength. How they are doing it is basically why industry chose NI technology for this cyber physical system is they have powerful graphical programming language. They have a powerful platform, nothing but your LabVIEW basically. So why this is basically considered very powerful, because I don't know how full-fledged the capability of LabVIEW. I don't know, because you people are studying it, you people are seeing it. Very important reason is usually when it comes to industry, the integrity is very important. I'll tell you what is integrity. See, now you are in the testing phase. Okay, so you want to test it in your simple programming language. Simple programming language, you want to test whether the application is running properly or not, right? Then you want to do it in a better level, where you want to put a very simple sample, a small product, and test the application on a small product, right? Now let me say I want to test engine, aircraft engine I want to test, right? So starting from the simulation phase to the ending phase of implementation or deployment, National Instrument, especially LabVIEW, provides you support in every single level. in every single level, starting from simulation to the deployment phase. That's why if you see, you can use LabVIEW for embedded system. You can use LabVIEW for a DAC system, simple DAC system. You can use same LabVIEW for robotics. You can use same LabVIEW for FPGA programming. Every single thing can be happening in a single tool itself. It's a very integral tool. You can do a lot of applications in a single tool. It integrates all together. Right, that's what I was trying to show you. It can use a simple DAC, very simple DAC, which is USB connected to your computer. It can execute that also. If it is sophisticated FPGA programming, so you can see that sophisticated FPGA programming can also happen. Even better computer design like OS. LabVIEW can support the OS of all. It supports Macintosh. It supports Windows, all versions of Windows, irrespective to its 7.0 or XP or 8.1.10. It supports all. And also it supports Linux. Apart from these desktop platform, it also supports microprocessor, microcontrollers. You can also program a lot of third-party hardware also. Apart from NI hardware, there are a lot of third-party hardware is also available. I'll just show you about that also. What are the different third-party toolkits are available that allows you to program them. I'll try to show you. So at least for this reason, at least for LabVIEW reason, NI has been considered as a very powerful tool for integration, right? So that is the reason one single LabVIEW application, how many domains it can serve. I was not having much space, so I was just limiting myself to for 20 list of 20. But basically, it can go even further. There are a lot more things which is basically having. See, what are the things which are most commonly preferred in industry? I'll just quickly tell you. Number one is point number 13. I would say R-ing buses. The avionic buses, the bus design, communication in bus. And next, it's going to be automotive bus, where CAN, LIN, flux rate, these things comes in picture. Then simple data acquisition, machine vision, 5G technology. Currently, if you see, people are very much interested on, the battery management system. I'll tell you why battery management system is a very important thing. Now, people are very much interested on an EV. What is EV? Electrical vehicle, and they want to design autonomous EV. So in this case, they want to use a renewable energies basically. So in this case, you have to charge your batteries, discharge your batteries. So National Instrument has come up with a complete toolkit on battery management system. So completely in and out of how to manage a battery, or what kind of applications you have to do, what kind of testing you have to do, on what basis the testing should happen, what type of validation you have to do, what type of certification a battery should be needed. All these things completely in and out they are trying to provide. Artificial intelligence, as I told you, machine learning, deep learning, neural networks, and there are a lot of applications that they are doing. And every industry are using LabVIEW and National Instruments. Okay, I'll come to that. What are the industries that are using and what type of applications they are designing. I'll come to that. So quickly moving into section 2, I was just giving an introduction about 4.0, Industry Revolution 4.0. And what makes people prefer 4.0? That was the bottom line of section 1. So what is 4.0 is basically designing a cyber physical system. What is cyber physical system? A system a machine that can communicate with each other in a smart factory. That is basically a cyber physical system. What makes us more successful in MA technology? The tool of LabVIEW. So it has all toolkits, which I'm going to show anyway. It has toolkits. Recently generated toolkits from National Instrument in the year of 2019, 18, and even 20. They have just launched a lot of applications and a lot of toolkits which supports the future generation of applications and technologies also, right? So just quickly jumping into section 2, Internet of Things. I'm just trying to break down the cyber physical system. I'm not talking much about the robotics, because it has been used in industry for a very long time by National Instruments, right? So that was even you people were seeing this entire 5 days, how to program, how to communicate with hardware, how to control a motor or whatever maybe it is. The automation is what you people are learning. But what I want to touch is Internet of Things. Many people doesn't know that you can implement it into IoT. It can be, there are different types of IoT. There are 3 types of IoT basically. Personal IoT, commercial IoT, and industrial IoT. There are 3 types basically. LabVIEW can be used. LabVIEW and NI technology can be used for designing all these 3 types of IoTs, right? So I'm basically concentrating this very small session. I have very small time to talk to you all about. I'm going to concentrate more on industrial IoT. I'll tell you why I'm concentrating on industrial IoT, because my aim is to talk to you all about the smart factory, where the application should be communicated through internet and in industry level, right? So I'm just want to talk to you all about the industrial IoT, IIoT. There is also commercial IoT. There is also personal IoT, which I'm not just most concentrating on that. But jumping into what is the IoT, I want to first show you people what is the IoT. IoT is basically Internet of People. So basically, what happens is we people communicate with each other through offline. We share our books, we share our music, we share our voice, we share our pics. We share our scanned copy. Anything, whatever, even programs, we share our programs in internet. We use a lot of medias to do this, like WhatsApp we use messengers, we use Gmail also. We use a lot of things to share. Now, for example, we are using a Google Meet to share my online session now, correct? So there are a lot of mediums to share our information to each other. So we people try to keep us connected, right? So this was a very big revolution. You know how big internet was a revolution. It was launched in the year late 1980s. When it was launched, right? It was a huge success. Computers and internet was a huge success. It was a kind of a revolution in our lifestyle. See, today, I don't know. I don't think so. Anybody in our country is not using a smartphone. Everyone are using smartphone. Unless they know to use a smartphone, they'll be using no smartphone. And if you are using a smartphone, you barely need an internet on that, right? You need an internet on that. And nowadays, if you see 1.5 GB is not sufficient for us. We know there was a time where monthly we used to recharge 1 GB. Vodafone and all, right? 1 GB they were providing, for 1 year, for 1 month, right? We were able to, be happily using it for 1 month, right? So, but nowadays they give 1.5 GB, but we are not sufficient with 1.5 GB per day. Now, literally speaking, I'm just using a pack like 2 GB per day, right? So sometimes I feel like in the night time I feel like it is exhausted, right? So internet has been widely used. We people are connected so badly that we barely need internet, right? So when we people are connected, we feel like we are more efficient. Absolutely, we are very efficient when we are connected together. Now that is what is going to be Internet of Things also. When machines get connected to each other, they are going to be even more better. All right. So why to connect internet, why to connect things? Basically when the things are connected, you don't have to intervene anything. If there's any process you want to do, for example, let me say you have AC. Okay, you have AC and you are using AC on a longer run. When I talk about longer run, let me say 2-3 years you are using one single AC. You don't know when it is going to be repaired and you don't know when the maintenance is needed for that. Now let me say this AC or any other product, whatever you have, it has an inbuilt system where it can measure its quality, where it can measure, when the maintenance needed, when the efficiency is reduced, and when there is a replacement of a spare part is needed. If it can measure everything and send a message to you, not only to you, maybe to the company which is designed. Now, let me say Voltas is sending a message to Voltas saying that this particular machine at this address needs a replacement on this date. Right, so you don't want to worry about that. On the right time, they will send the person to replace it. You don't even know sometimes. Maybe your machine was needing a replacement. Your machine is talking to the the developer saying that, hey, come on, I'm feeling sick. I need a replacement. Right. So this is very important. Correct. So when these machines start talking to each other, let me say already we people are not. This is not new thing for us. Or whatever you're using, like phones, whatever you're using, it's basically Internet of Things only. Right. So because it communicates with each other, it can talk, it has a lot of sensors, it knows what is happening to it. If you see, there are some options to check what is the battery maintenance, what is the battery, capability. All these things are already there in phone. So more like phones, we are going to design all the products to be, the IoT design. So for example, let me say I have a pen. I have one pen in my hand right now, So I want this to be an IoT device. I want it to be an IoT device where it talks to, for example, let me say it talks to the paper, because it writes on the paper, right? So it has a sensors to it, so it will listen what I try to talk, and it writes itself. I want some machine which does that. I don't want I want one person to sit next to me and whatever I say he has to make a note of it. I don't want a PA to do that. Rather, I want a machine where I keep saying something, it writes it. Even now we have it, but we have it in a soft copy. Say, because when you see, you go to WhatsApp and you have to type it, rather than that there is option, you can speak, it recognizes your voice and it tries to type itself, voice to speech, voice to text it does, correct? Something like that I wanted in a hard copy. So when I talk about hard copy in a paper, I want it to be written. Why not? It's possible. It's possible. Obviously, it's possible, right? So these kind of applications are needed to be done. Then you need an Internet of Things. For example, let me say you people when you miss a phone, what do you do? When you use, let me say you don't know where you left your phone. What do you do is you ask a friend to give a call to it. You ring the phone and you just try to find it out. It's easy for you to find it, correct? So now let me say, you missed your specs. You have a specs. I don't know. I use specs. I every day miss somewhere. I don't know where I keep it. So what happens is I can't ping it. I can't call what to say. The specs and find out where it is. That is not possible, right? So if this was a IoT device, let me say my watch was IoT device, my specs was IoT device. I lost it. I can ping and find where it is, right? Or let me say they are all connected to one main computer, where I can check in the computer where all my objects are. Where did I put? For example, let me say I'm packing a bag and I'm just going for a travel, right? I have a list of things I want to pack. Sometimes you miss it, am I right? Sometimes you miss it. Rather, I just ping my bag and ask what are the things you have, right? My bag will give me the information of what are the products have been loaded, what are the products have to be loaded, what are the products are missing, right? So it makes the life more comfortable. That's what IoT is needed for all the objects. So basically, we people are now using a common normal things. What we need to be, converting a normal thing into IoT thing, it needs a sense and it has to communicate. What is sense? It has to understand the environment. So you need a sensor, and then it has to communicate with each other, or at least it has to communicate with me to some extreme. Okay, so sense and communicate is actually the key. You have to add sensing ability and communicating ability to your normal things what we are using in day-to-day life, right? So our human beings have 5 sense organs. We know all the 5 sense organs. Same as such, we are supposed to add some sense organs to your objects. For example, your phone. Your phone has senses. It has a lot of sensors. And then nowadays, there are some smartwatches. It comes, it tracks how many kilometers you have walked, how many steps you have walked. It has all this information. And then there are some more systems like not in India, but in foreign countries, if you see, especially the cold climates, they have thermostats where basically it will measure the temperature. It tries to maintain. It understands how many people are in a room, what is the temperature it has to maintain, what is the external temperature, how much it should be the internal temperature. It tries to monitor everything, right? So these are the IoT devices that are already there. Now, for example, Alexa. I think you people will be seeing Alexa. Alexa is one product which is basically an IoT device where it can communicate, it can control, it can communicate and control, it can sense also, correct? So how a basic individual IoT device should look like, very important. How a designing IoT device should look like. Basically, it should have n number of sensors depending upon the application of the device, right? Depending upon the application of the device, it should have n number of sensors inbuilt on that. So when I talk about sensors, it has to be acquired, it has to be processed, it has to be controlled. So you need a processor in it, a control unit in it, right? So when I use a control unit, it needs a battery basically. A control unit cannot be a standalone. It basically needs a simple battery. At least a simple battery is needed. That's where NI came up with battery management system. I told you. See, when you want to design for example, I'll tell you why it's so badly needed. You have a phone, correct? You have a phone. I at least charge my phone once or twice a day. Mostly twice a day. There are some days where I charge only once, right? So now think, this is an IoT device. I told you, phone is already an IoT device and you need to charge for this phone, correct? So now think, in your home, all the products, let me say you have 100 products in your home. All products are IoT devices. Then even they need charge, correct? So that's a huge problem you'll be facing when it comes to battery in the future, because all IoT devices need charge. So when you want to charge it, it's not going to be possible to fix 100 plug points in your home. That is never going to happen, obviously. So you need to have a standalone batteries. And these batteries should be like your phone. Your phone battery drains every day. But your normal batteries, which you're going to use in the future, should not drain every day. It has to be on a longer run. Like it has to at least work for like 6 months minimum or like 1 year minimum. Only then you can rely on that. Because replacement of battery itself is going to be a huge budget for you in the future. Am I right? Because every time, let me say, every 1 month you replace, you have 100 products. Every 1 month you have to replace one battery for all the 100 products. It's not going to be easy, right? So battery management system is one of a very, very hot research things people are working on. Even for phone, if you see nowadays, there are some, people are looking for, phones which has higher battery life, correct? So there are a lot of products coming up with a higher battery life. I think someone is unmuted. Can you just mute it? Hello? Can people mute it? Hello? Yeah, thank you so much. Thank you, thank you, thank you. So following next, you should have a device. These are all the add-ons to the device. You have a device which is doing the task, then you need a sensor, then you need a control unit, then you need a battery, and then you need a communication medium. Only then it can communicate with each other, correct? So entire these things should be embedded on a single object. Any object you take, let me say you take a purse, or you take a pen drive, or you take a, the specs, whatever it is. Every device should have these things inbuilt. A number of sensors, batteries, and a control unit, and also communication medium to send the data and receive the data, right? So now let me say the n number of, before I was talking about one single device, right? One single device should have this. In the future, when all the devices have this, they will be communicating to each other through an internet, right? You will have an internet, a common internet, and it communicates from one place to another. The devices will be communicating from one place to another, and this is common. Whatever I was telling till now, it's common. Okay, now I'm going to quickly tell you about the difference between different types of IoT: commercial IoT, personal IoT, and industrial IoT. Depending upon the the size of the reach you can take in the internet. For example, let me say you have LAN, right? LAN, you have Bluetooth connection, you have WAN connection. So depending upon this, personal IoT basically uses your Bluetooth connections, right? Which means a very small range of communication area. Number two, it's going to be commercial IoT, which basically uses your Wi-Fi. When I talk about Wi-Fi, within a home range, in a single home, the range of your Wi-Fi is always within a floor, or within one particular home, right? One particular building, mostly one particular building, right? So that is basically where it's a commercial IoT, right? Then comes industrial IoT, where you want to push it to the cloud, a real industry, cloud, where I have to communicate the data from India to America, or from wherever I wish within this entire globe. That is basically called as industrial IoT. So depending upon the reach, depending upon the size of the reach you people have, that classifies into industrial IoT, commercial IoT, and personal IoT, right? So if time permits, I'll also show a demo, but I will finish the topics all, and then if time permits, I'll show a demo. I have left out with so nearly half an hour to 40 minutes I'm left out with. So I'll just quickly go to, because I want to also talk to you all about, the scope of the future also, because as of now, I'm telling about what is happening in the current, scenario I'm talking about. I want to also talk about the future to you people, and also how industries and national instrument is doing this in industry. I want to talk to you all about that, and also job opportunities. See, I'll tell you, I personally, I believe in one thing. I don't know, maybe it's not the same for all. You people are learning this something for six days now, correct? 6 days you have spent your time on doing this, correct? So this has to make something benefit to you people, not just simply sit, watch, and maybe, yes, I might think about doing a research work, right? But I don't know how many are going to really do a research work, or how many people are going to just think about, getting your students placed there. That's very important, right? Because all the college people, all the students study. Why they study? What is the purpose of their studying? They have to get a job. They have to make their living. They have to, get into good standards, correct? So if you're doing something now, let me say only 1 hour you're sitting and working on this NI technology. Just do it if it is going to make some sense to you in the future, correct? So I want to tell you about after this, because I don't think so, in any of the session, anybody would have spoke to you all about the, placements and where the opportunities are, what kind of skills needed for any student to get a placement in industry. I don't think so anyone would have been spoken. I don't know, because I was not following the entire sessions anyway. But let me say, I want to just, give some inputs towards it, because being in industry, I know what is the expectation from your students. And I've seen some students also, and I know, in a lot of interview process also, right? I know what students lack, right? I'm just trying to want to bridge that gap, a very small gap that's needed not to be bridged. So what industry needs and what the students need to do to sell them in the industry. I want to tell you all about that. So I need to use 10-15 minutes badly on that, because that's very important to me from my point of view. Artificial intelligence wise, and I use a lot of artificial intelligence technique nowadays. Machine learning, deep learning, neural network. These are 3 major artificial intelligence techniques that are being used in current technology. National Instrument use all 3. I can just give a very quick a demo on that. A demo in the sense how to do that. See, I'll take a LabVIEW. I think you people have been using LabVIEW. Let me quickly take a new VI. I'm not going to do anything. I can show a video because these videos don't need, volume also. I don't know what is this problem, because today when I was starting the session, the mic was not, connecting. Now the speaker is not connecting. I don't know what is the issue, but it's okay. I'm glad that you people can at least see and hear me. Okay. See, on the block diagram, if you've done a proper installation, for example, let me say machine in motion, you will be able to see machine learning, right? Can you see machine learning, everyone on the screen? Machine learning, right? Inside that, you also have deep learning, right? So these are some toolkits that will be used, for machine vision application. I think today, last session, I think it's about machine vision only for you people, where you'll have some demos on that. Because I was going through the, the schedules. Apart from that, for every domain, for image processing, you have a separate tool. There is a separate tool for, for signal processing. There's a separate tool for, machine learning algorithm analytics, for other toolkits also. So there are a lot of applications involved, but I can quickly show you people how a LabVIEW application can look like. For example, I'll just play this video. This is a deep learning algorithm, basically. And I'm fine if the audio is not available. Yeah, the audio is once again not available. See here, you can write any font you wish, any number you wish. And this entire system is a classification, deep learning based classification, a decision making algorithm being used, where it finds what object or what number you're writing. So basically, when you write it number 2, it's like optical character recognition. I hope you people know that. It's an advancement of that. So you can see that it is classifying what letter you're writing, right? So you can see that for the value number 2, you can see the score is 1. The other values are all 0, right? So I'll just play this. You can see. Yeah. So whatever character they write, this you can see that. Yeah, it is giving the scores. Yes, and every character, right? Great. Yes. So this is optical character, but I'll just try to show this one also. I'm glad at least this one has good sound. I'll just play this. Just see this real-time fruit detection. This was also using LabVIEW only. Can you see LabVIEW program? This is a LabVIEW program. Can you see? It detects what object it is. It comes along with a score. Yes. So this was one more example of how a deep learning algorithm can be implemented. Because I was showing about a character, right? But it was in a software level. But I want to show it can be integrated to a hardware. Like it can be anything. It can be signals. It can be images. It can be videos. Yes, you can do it. And you can see that these kind of deep learning algorithms are also nowadays there are a lot of research going on communicating your deep learning algorithm along with the 5G technology. Right, to sense the the white space in the frequency domain. So there are a lot of research work going on to implement or impart your deep learning in communication also. Right. So I have one more video because I don't want to leave this video. I'll just play this video. This is like how life can be better with IoT. This was I usually used to show to students, because to make them understand how your life will look luxurious, when objects starts communicating with each other, right? This video is about that. Just watch. About IoT. This is about IoT. Finishing this video, I'll get back to the the topic basically. So you can see that once the people enters into the home, the objects inside the home gets started. It starts understanding that the person has come into the home and what has to be kept ready next. It knows it. You can see preheating is happening and everything is kept ready. You can see the room, the doors get locked automatically, right? It knows that there is someone inside and they can't use that room again. Automatic lights off. It knows what are the products available, what are the things are missing. Once you can wake up the kids from the kitchen itself. Before starting, you can get all things checked. You can see to avoid delay, you have to leave now in 3 minutes. You can see that the door was left open. It reminds them to close it. You can see before he comes, all the entire room is ready for him. It has all the information about the meetings also. You don't have to be in your home when the maintenance person comes into your home. normal face recognition system and live video. Once everyone go to the bed, you can see all the lights are off. Starting from the day start to the end, entire things will be controlled. That is how, if this happens in industry, that's basically called as a smart factory. That is all the references, right? So hope you have an idea now how, applications in the future should look like, right? Okay. Excuse me. Okay. Right. So National Institute has been using, a lot of, technologies in the recent time. See, these kind of deep learning and machine learning algorithms were not available like a couple of years before. Right, they are like launched very recently, and it's completely, every year they are just trying to add some more new features to it. They're upgrading. That's the reason, if you see, many people ask me a lot of queries related to this, especially the students community ask me, what is the reason NI provides, every year they release one software, right? Every year badly they release one software. The reason is they want to upgrade the technology, right? You might think that this toolkit is already available last year. Why was this, upgraded? Because there are a lot of new technologies coming into the picture. That's the reason, right? I'm just moving to the very last section. I somewhere consider this one to be one of the very important section. So how NI is being used in industries, and what is the plan of National Instrument in industry, right? So if you ask me, right, basically what National Instrument is basically doing, or who's using National Instruments technology, all the companies that are basically using, the production-oriented company, production-based company basically use NI technology. And I told you the reason also. What is the reason why companies are using NI technology? The reason is it has a software which is basically gives a very versatile software. It's a very versatile software. What I mean by versatile is, see, your application is now building, somewhere related to semiconductors. It supports you, right? So immediately after, sometimes you have to use it in a different tool, a different domain. Let me say you want to go for, flight craft testing. Once again, the same tool is being used, right? So it makes it more versatile. Many people start using it, and because of this, there are a lot of opportunity for the developers to mingle with other domains. For example, if you see, Cisco and Siemens are coming into picture for this. There's something called TSN. I don't know how many of you know what's TSN, time sensitive network. National Instrument is actually playing a very vital role in designing this TSN, because they are providing all hardwares. Because the products have been designed by Siemens, they are controlled by National Instrument, and the complete networking is being maintained by Cisco. So all these three companies are coming closer to bring, TSN network. See, this allows, other companies, other technologies also to mingle with each other. So it can be, very effective. And you can see here all types of, industries are there. Networking industry is a semiconductor, and AMD is a semiconductor because it's a chip designing company, AMD. Okay, they provide, the graphic card, RAM for your computers. Then you have Philips, that's also electric company basically. And then you have Yokogawa, ABB, Siemens. These are all, automation companies. Being NI, an automation industry, most of the automation companies uses NI technology, at least to validate their solution. If you ask me, Honeywell, right? Honeywell doesn't use NI technology basically in development. Basically, they use PLC and SCADA for development, but they use NI technology to validate their, the products. They produce products, so they validate with using NI technology. Develop with PLC, SCADA, but validated with NI technology. That makes it very powerful. And then you can see Boeing, NASA. These are all, the flight aircraft companies. Rocket science, basically NASA uses. There are a lot of automotive. We can see that a lot of automotive. Ferrari, Honda, and then Nissan. There are a lot of automotive companies, Ford, right? So most of the product-based companies basically use NI technology. As I said, they use solutions starting from the simulation part, from the the testing part, simulation part, whatever it is, all the phase. National Instrument provides a solution, right? That makes it more versatile and being preferred with most of the industries, right? So this is the very, very important thing which I want to tell you. I was telling to you all about, currently what NA technology was basically targeting, like down the lane of 10-15 years, National Instrument basically wants to concentrate on smart factories. So now talking about the longer run, I was talking about the century. They have a plan for the entire century, I was telling you, right? So what plan National Instrument basically possesses? They want to concentrate on only specific field. They want to concentrate on not all the verticals. They want to concentrate. They have to narrow down for some of the specific domains. Number one is semiconductor and electronics, where the battery management system, the electrical vehicles, everything come into picture. Automotive, it's a club together. Automotive is also about the not only the when I talk about automotive, not only the the cars or the automations. I mean, automotive is involved. There is also communication system behind them, because they basically use when I talk about electrical vehicle, fully it is automated nowadays. You see Google is also trying to design a driverless car, right? So fully automated. So on this case, how NI is basically working is basically they are using IoT devices. They're giving IoT solution. They're also giving the 5G internet, because if you see in the fourth point, there's wireless, because NI is working on 5G testing also. Automotive, they want to, for doing the driverless car, they're giving 5G solution also, IoT solution also they give, machine learning algorithms also they basically give. And then comes to aerospace, defense, and government. This is the field where NI has been working for a very long time, very, very, very long time. Because if you see the profile when you are giving introduction, right? We have been working on aerospace. Personally, when I talk about VI solutions, I mean, so we are working on aerospace and defense projects a lot. Now currently, like nearly 2 to 3 decades, we are working on this, technology, aerospace technology. Not only the communication part, not only the testing part. AT system, ATP system. AT is like automated test equipment system, and ATP is acceptance test procedure. Where, let me say, when one mission, when one engine is designed for aircraft, we have to do the testing, and you have to certify it, saying that it can be used in a commercial level, or it can be in a defense level, whether it can be used or not. Those kind of certification. To do the certification, we need some tool to test it. So we designed some of the applications using NA technology to test those hardwares. And basically, if you see very recent time, National Instrument has now concentrated more on HIL. I don't know how many of you know what is hardware in loop. Hardware in loop is nothing but before coming up with a complete product, they will simulate the characteristic of that particular hardware. For example, very simple example, let me say the engine of a airspace. I'll just take the same example because we have worked on that. I have a complete idea about that. That's the reason I'm just using that. I'm picking up the same example every time. See, let me say there is an engine. We have to test the engine now, right? So we have to test the external condition on that engine, so that you have to know how much the strength of the material has to be increased, or like what kind of controls you have to use, or what kind of protective, the shieldings and other things you have to use. You have to test it, like, let me say. So rather than designing that entire engine, then test it, then you understand, no, this has to be changed. You have to once again come up with a new version, and once again test it. Something else is going to be bad. Once again you bring up with a new version. Rather, you should use a device which simulates or the behavior or the characteristic of that particular engine, right? For example, let me say this engine is going to have a load of, like, let me say, or pressure of, let me say, 10,000 psi. Let me say it is going to take 10,000 psi pressure on it. Now what I will do is I will just simulate a hardware which can provide a 10,000, because NI also has a lot of simulation cards where it simulates the load, simulates the pressure, simulates the voltage, simulates the temperature. It simulates all these informations, and you'll have to test everything with that HAL model. So it's a hardware loop where you'll loop it into your application. That hardware will be looped into your application. You do the testing on that particular device. Then you come to a conclusion, for our application, these are the X, Y, Z standard needed. Then you go for the production. This makes your life very, very comfortable. You don't want to spend your life on, like, design a product, test it, something is bad, replace it, once again test it, something is bad, replace it and test it. You don't want to do that. Rather, you have a HAL product. Basically, we use PXIs. There's something called PXIs. So we use PXIs for HAL. So this PXIs will act. You have a lot of modules which will simulate the behavior of a particular engine, right? Whatever maybe it's needed for the engine, it simulates the performance of that engine, and you test all the criteria of that engine on that HIL device, on that PXI itself, and then you come to a conclusion. Okay, fine. To do this model, to do this this mission, to do this engine, I need these are the things I need to take care. Right. So this is basically called as HIL. Aerospace in aerospace region and national institute are doing a very good job. That's why even we people are not sticking to it. If I felt something else was better, I would have not been preferring NI technology. I'm giving solution to any of the companies using NI technology. Right. So the reason is I feel like this is the best one. They update themselves. That's a very important part. See, if this was the case, whatever technology they have been using, let me say in 1990s, they're still using the same technology. I don't have to prefer this. But if you see, every year they update the new things. I am challenged. I have to learn myself first of all. I have to upgrade myself first of all. Even though I've been in this field for now like a couple of decades, I'm just in this field. But I have to update myself according to NI technology, because they are very much updated compared to me. So I have to go through every time, just check out what are the new things, added new things, what are the different types of controls they have. See, genuinely speaking, there are a lot of communication techniques which I am not good at. For simple nowadays, if you see, when I was working on project level, down the project level, right, we were not using sensors that were like protocol based sensors. Nowadays, if you see SPI, I2C, UART, there are a lot of sensors coming into picture in the market. I was not working on these things. I was working on a simple sensors where we just connect through wires and we just try to excite them with a current or voltage, and we have to measure the data. This is what we used to do. But there are a lot of new things coming up. And if you see, even before I know that these are things coming up, I see these things are included into the NICE toolkit. Right? That's why I come to know that, okay, there are a lot of more things are coming up. I have to upgrade myself. Right? And then energy. Wireless. Wireless is basically the 5G. Next session is going to be on 5G, where they'll be talking to you all about the full-fledged. Basically, National Instrument are using a hardware called as USRP, and they are doing like a lot of things on research of 5G, and basically not my field. I don't work much on that, but I know what are the things they are doing. They are working on cognitive network, incognitive network, trying to do MIMO technology, 16x16 MIMO, still 16x16 or even before, because I know that people have done some 16x16 MIMO and at very cheap cost, 2x2 MIMO at very few amount. They're trying to establish. A lot of colleges are also buying NI product for 2x2 MIMOs in communication departments. Now I've seen people doing it. It's a good, nice thing, initiative that students can learn 2x2 MIMO in their college level. It's a great thing. They are able to provide some of the solutions in a very low cost. That's very important. And then coming to energy transmission, engineering. The grids, microgrid, then the smart grids, maintenance. All these things. They're working on a great level. And then academic and research. All these things related to what can be the future. They parallelly also working. See, today I'm just giving you some 6 points and saying these are 6 things what NI is going to work on this entire century. But the 6th point, which is talking about academics and research, is always keep ticking whether this is needed, this is not needed, this can be included, this need to be removed. It keeps ticking. Maybe in a couple of years, you'll see that the list is going to be only 4 or 5, or maybe it is going to be 8 or 9, because we keep on researching. NI keeps on researching what is needed, what is not needed, what has to be included, what has to be removed, whether it is updated, whether it will be needed for the current technology. Because the plan is for the entire century. Think about the entire century. They're more concerned about not what is happening now or what is going to happen in a couple of years. No, they are talking about the entire century. This entire century, this is the plan for NI. They want to master these verticals. That's the idea. That's how it has to be. The vision has to be there. NI is having a vision, and they're also having one more domain. See, these are all the domains where the industry works on. This is a domain where National Institute works on a lot. They keep on researching. They keep on thinking what is needed, what is not needed, which is a very, 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 very important aspect for any of the company when it comes to industry, because you have to understand the future. Until you understand the future and take some precautions. See, when nobody was thinking about IoT, NI was able to provide some hardware in the year of 2008 itself called WSN. Now they can produce. Now they have produced. Now when it is a hot research, when everyone are thinking about bringing a new hardware on IoT, NI has given a hardware which was in the year of 2014. NI has brought a complete IoT device. I don't know how many of you know a hardware called MyRio, MYRIO, MyRio. This hardware is basically an IoT device. Basically, it's an IoT device which has sensor. I was telling you, right? It has sensors. It has a communication medium also. It can connect to Wi-Fi. So when it can do, it means that it is IoT device. Now you have to think about how it has a power supply also. Basically, talking about the battery management system, it has a power supply also. So in the year of 2014 itself, even before people know what is IoT, what can make a future on IoT, we were no one knowing about IoT at that age. 2013 basically, not 14, 2013. National Instrument came up with a product called MyRio, which is actually an IoT device, right? So this is how National Instrument are basically working, talking about thinking about the future, right? So like I have some more time, like 5-10 minutes I have. What I'll do is I'll just quickly talk to you all about the opportunities. That's what I want to just basically show you people. Let me take see, I'll tell you. Oh, just a minute. I'm taking a. It's not loading. Yeah. I'll take a new window. I'll try to quickly show you people, how you people have to work on. See, ultimately, to your students, what you have to do to your students is basically. See, I'm glad that some of the what to say, the universities are now understood that what industry needs and what syllabus has to be updated. They are now aware of it. Now I see most of the industries are updating themselves. No, sorry, most of the syllabus are getting updated in the college level, but still somewhere I feel like there is no proper mentality has come to the students level. Now students level I'm talking about. See, I'll tell you one simple example. One of a famous NIT college, right? MTech, instrumentation MTech, there was elective paper to be selected. Okay, they are supposed to select the elective paper. The students were not choosing mission. There's something called, they have a subject called MI. Okay, it's like mission intelligence. Okay, so to that there is something extra elective paper called as optimization. Okay. Optimization is basically how optimal you can design a system. Basically, it's a back end of your the deep learning and machine learning algorithm optimization basically. Okay, so when I saw the list of students, they selected the elective paper because they said that we want you to give some lecture on that. I was asking what subject the students basically study. Then they sent me the list of subject they study. I found none of the students, like hardly in a class of 30-40 people, there was like hardly 2 to 3 people have chosen MI. MI basically is mission intelligence, but majority of the people, like 15 to 30 people, 15 to 20 people, have chosen optimization. They have not chosen MI basically because they don't even know that, or they should have understood that optimization is a backend of MI, and until you study MI, no, ultimately you don't have to study an optimization. The students were thinking only about scoring marks. It's a derivative paper where they can simply derive that equations and get some marks. It's a very, very bad attitude, I somewhere feel. So the students need some education, right? So talking about the industries, right? Now a lot of industries are now ready to give internships. You should look out for internships to the students, and I want you people to promote not one internship. I know universities are asking students to take one internship for compulsion. I know that, I agree, but somewhere I'll tell you how a mentality of the student should be. Now let me talk about VA Solution. VA Solutions have some projects. Let me say one project span is 1 year, right? So once I do a project, what happens is, and if my customer is satisfactory with my project, what they do is they come up with one more project, because they keep on working, I keep on working, right? So first they give one testing. When it is successful, they give one more testing. And when that is successful, they keep on going. Now what happens is, my customers, my clients whom I'm working with, we are working for a longer period. Not for like 2 years, 3 years. We work, like 6-7 years. We go in a stretch. In this case, what happens is, when the students are being part of us. Now, let me say in the second year, the students come as an intern to VA Solution, for example. Okay, what I do is I ask him to work on some technology. I ask him to do some of the applications which is related to my project. I give a subset of my project to the student, ask him to complete, and he does it and give me. So he now has an idea of what I'm currently working. Great. Thumbs up. Okay, good. Now, going to the third year, student should prefer going for the same company for internship. Why I prefer the same company is now a new set of projects has come, a new set of technology has come, new set of trending tool we are being using. So after second year, the students are working with me once again for the third year. They understand what VA solution is doing for past 2 years. Now the same set of students, when they come for the fourth year again, to VA solution, I'm not expecting the students to be here for 2 months and 3 months. No, it's all about being here to understand the environment. I'll tell you why this is very important. Before I finish this, now the students is being in a part of my company for the third year again. So as an intern. So now the student knows from the second year to the final year, he knows only NA technology. He knows what BI solution is doing. He knows what entirely how a testing of an aircraft is happening. The student knows it now. All right. Now in this case, the student is supposed to do a final year project. Am I right? What will he prefer? Basically, the mentality of a human being. Basically, he knows that he has been working on this for many years now. 3 years he's been part of it. He will be planning to do more related to these stuff, which gives him a very good opportunity to get into industry. Because when you do a final year project, see, for example, genuinely talking about in the Indian standard, Indian market, right? Now I want to recruit some 5 people. Okay, where should I go and check? I have to go check in the colleges only, right? So how many colleges are giving EC? Let me say I want to do recruit a EC BTech graduate. Okay, so how many colleges are there? How many students are there in every college? How much time I can spend on recruiting 5 students? I should have a criteria, correct? That is where your CLAD certification comes into picture. We are always, NI promotes CLAD certification, CLD, Certified LabVIEW Associate Developer, Certified LabVIEW Developer. So these certifications allows me to quickly filter out the required student. Now I have, once again talking about that, I have a bunch full of, CLAD certificate students. What should I see? When I interview, right, I just give chance for all people. In your college, let me say there are like overall 60 students of final year, and which 25 people are not CLAD certified. Let me say I want to recruit them. I want to find 3 best candidates out of it. Now what I have to do is I look out for the all student and I just conduct interview for all 25 people. How much time I can give? I can give 5 minutes for each student, right? In the 5 minutes, what will I be trying to see? I'll be trying to see what the final year project the student has done. Why? Because that is where he shows his interest. Because internship and final year thing is only thing where the student need not follow the college syllabus. Usually, other things are all college set syllabus. College is being setting the syllabus. Whereas when it comes to the final year project, it is of his interest. Coming to internship, once again, it is of his interest. Now I can see what he is interested in. I can see what he is specifically expert of, right? So in this case, when I see the final year project, I see the internship, everything bugs me, Basically, when I see a student's resume, when I see a student has done some X, Y, Z projects, right? So what goes in my mind is there anything related to my application, what I'm currently working? Because I'm recruiting a student for my current requirement, right? So I just see whether anything matches it. So when I see a student who has done a HIL-based aircraft testing, let me say, I'll feel like, yeah, I'm working on aircraft testing. The student has done HIL because I need it badly. So I want to go talk to him about what he has done, what kind of application he has done, what kind of tool he has been used. I want to see whether he's upgraded. So how will he be upgraded? He is working with one current industry for second year, third year, and fourth year. He's continuously working. He knows all the for past 3 years. He knows all the in and outs of the that particular domain. For HIL testing, in the second year he was studying, they were using like SolidWorks. Next year they were using like multi-synthesis. Next year they were using like test time. So he knows now what are the in and outs is there. He knows everything. He is considered as an expert. I want a student like that. Anybody will be needing a student like that. See, in 5 minutes it's very hard to judge a student. Trust me. In an interview, when we sit in an interview and we are trying to ask questions to students, and especially when I want to find out the best candidate, it's very hard to interview within 5-10 minutes. Trust me. So I can give a minimum of 5 minutes for everyone, and whoever impresses me, I'm going to give one more 5 minutes to him. Right? But now I feel like he's so so mind-blowingly he's talking, which is more related to me. I want the student to be at least as a as a at least as an intern, as an probation period, I want to give a chance to the student. You understanding? So that's what goes in our mind. That's what goes in our mind. So your CLAD certification, your certification for national instruments is a vital key. And moreover, if you want to know what are the companies, right, I'll just quickly show you. I just, for example, show you what are the things NI alliance partners basically do. What is NI alliance partner? NI is partners, I mean, the industry that use NI technology basically, in extensively who uses, they are called as, NI alliance partner, right? When I talk about NI alliance partner, there'll be a list of companies that are been using NI alliance partner. You can just go check their websites basically. And understand what these people are doing and what your students should do to get into a placement of that. Because in their website, if you see, I'll just open NI Alliance Partner directory. If I open that, you can sort out based on the country and based on the application what the companies are working. I'll just quickly show you that, because with that I'll wind up because it's already late. I'll try to show that. And further queries, anything related to this, you can just post me. I'll just give you the mail ID to post also. Right. Location wise, let me just quickly sort out in India. Right. I'm just choosing India. Can you see the list of companies? You can read out what these people do. For example, let me say number one company here is listed out as Captronics. You can see their alliance partner, and they work on sectors like aerospace, defense, nuclear, telecom, automotive, and manufacturing. And what is their specification? They are working on RF and wireless, right? And what kind of certification they are expecting from their employees basically is architect, CLA, Certified LabVIEW Architect, Certified LabVIEW Developer, CTD, Test and Developer, and then CLED, Certified LabVIEW Embedded System Developer. Right. Then let me come out Digilogic. Once again, you can see that they are working basically on aerospace, automotive. Coming back to Conrad, can you see they are working on IoT and automated products, right? So CGS, they are working on basically sensor calibration equipments, right? The products, semiconductor products. So all the companies, you can just go through their websites and see what these companies are basically working at. And if you go to their websites, you will see that what are the requirements they basically give you. Right? What are the requirements the students they are expecting? Right? So you should first train your students, ask them to first plan. They should plan what they have, where they have to settle in. So if they choose, for example, I know this domain, so I'm just talking about it. Let me say they choose, some like some AT system developer. He wants to become an AT, automated test equipment, developer. Then he has to now start working on those part of or the in and outs of the ATE from the beginning, not on the final year. See, the students, I know the students how they select. They go to the final year, then they think about their project. It is not going to work that way. Trust me, they have to work from the beginning, from the second year, from the third year. So they have to plan accordingly. See, unless they have a wide knowledge of that particular domain, he will not be able to choose what to do. He'll randomly come and ask this faculties, what kind of project shall I do? Then they'll go to the project centers. I have been even seeing students, a lot of students go to project center and they try to procure their project, which is bad, very, very bad. They should do it. So unless they do it right, what is the point in doing engineering? So engineering means doing it, correct? So they should know that. So you should just promote the students to work on a lot of projects, not one project. See, college is the syllabus recommends students to do only one project. The university recommends them to do only one internship. They need not settle for that particular number. They can go for more. The more they go, the more they learn. And there are a lot of industries that are like happy to invite students for internships. Ultimately, what I want is you college people should encourage them. See, unless he has a permission to go to a company for 10-15 days in the stretch, unless you people help them to do that by giving the right permission to do that, I don't think so the students will be able to do it. See, and when you try doing it for 1-2 students, right, it becomes a habit for you also, and it becomes a habit for the students also. In your college, the students don't go for one internship, they go for like 3-4 internships. So that's even a nice thing for your college also, right? And by doing this, I personally believe by doing this, basically, you don't have to take care of the placements for the students, because the students will have the ability to place themselves, right? Because they are a part of industries for 3-4 years already. So they have the ability to place themselves. You don't want to fall behind the placements. It is like it's a process what you have to do. Like outcome you want, you have to start doing the process from the beginning. Don't expect on the last part, happen. I somewhere talked to many colleges about this. I don't know how many initiatives they take, I don't know, but I'm just trying to tell my ideas. when you give a proper knowledge to the student, you don't want to bother about their placement, because there are n number of placements are already openings are there. No, the only thing is the right student has to sell himself to that particular job. He has to have the ability to do that. If you people can allow it to do, and ultimately nowadays, since because of this, thanks for this internships, you don't have to sit and teach them everything about the industry. They can go and learn themselves, and they can establish themselves. And ultimately what we need from you is proper support as college people. That is all I just personally request for new people. Yes. And with this, I'll just close up the session. It's already I just gone over the time. Thank you so much. If there is any queries and any further talks or further related queries you have, not you, your students, you can just ask them to reach me also. They can reach me at support@vaisolutions.org. Okay, support@vaisolutions.org. All right. Yes.
Yeah. I have one question
Yes.
from your end,
Yeah.
from Nagarjuna College side. So, are you providing any internship opportunity in your company for
Yes.
our students?
Yes, we are currently recruiting some of the students for internships. So if you want some information, just ping me at support@vaisolutions.org. I'll provide you all the information related to that. We are currently recruiting for winter internships. It will be probably starting in the end of this month or maybe in the Jan. We are not having one batch. We are trying to plan for 3-4 batches, where even we are not finalized the dates also. So it's early stage, for your students to enroll into the internship. Not a problem. You can just ping me. I'll just try to provide you all the information what you need related to that internship enrollment. Yeah.
Okay. So
Yeah.
one more question related to the presentation.
Yeah.
See, Industry 4.0 is there. So how
Yeah.
much time it may take to switch over to that? Because so now 3G to 4G, it has taken a lot of time to switch over when we
Yes.
talk about telecom industry. So now
Yes.
they are talking about 5G. Maybe another 2-3 years we may expect to switch over 4G to 5G.
Yes.
So
Yes.
so many jobs will be lost, and
Yes.
what is the impact on that? So can you?
Yeah, exactly speaking, it's a process. In the process, there will be a lot of losses also. So ultimately, the thing what we have to think about is, if something is going to make a future, we have to make sure the students will be ready for the future. If you prepare your students for the current technology, obviously in the future he will be losing his job, right? So if your student was ready for the future, then yes, obviously there's going to be a lot of chance that he or she may not be losing their job. And ultimately, right, this is not the end of the world. There are a lot more technologies coming up also. So the students should identify that and start working on that. Ultimately, what an employee should do. Let me say I'm an employee. I'm having owning a company. Let me say I'm running a company. If I want to not get lost in this business, right, I should upgrade myself. Until unless I upgrade myself, right, I will be in this business anyway, right? So losing job until unless you are ready to learn and upgrade yourself, you won't be losing job. That's what I see, because any new technology is emerging, right? New employment also emerges. Even though there are many people losing their jobs, many people are getting their jobs. Ultimately, see my company, right? Let me say I have one employee who's working here for 5 years. A new technology comes. If he can work on the same technology, I don't want to recruit a new person, right? So he will not be losing a job. So that's how it works. Keep on upgrading yourself. You don't have to, get to the issue.
Yeah. Thank you so much, sir, for the session.
Thank you.
Rambabu sir, are you there? Rambabu sir. Okay. So from Nagarjuna College side and from the management side and principal side, so I thank you so much for the for your time, sir. So 1.5 hour, I was watching the entire industry 4.0 to that technology what you have shown video. So I think all our participants are benefited. Thank you so much, sir. Thank you
Thank you
so
so
much.
much. My pleasure.
Yes.
I'm really happy to be invited. And I'm glad that I shared some of the knowledge. It's a very short span, very short sharing of my knowledge. But I believe that it's going to be effective for most of the students. I believe that addressing faculties is very important,
Yes.
because you can address a lot of people. I'm glad about that. Thank you so much. Thanks for this golden opportunity. All the very best for everyone and even your students. Thank you so much.
Yes, sir. Thank you for the support, sir. We expect
Sure,
same
sure.
support in the future.
Always, always,
Thank you, sir.
always. You
Thank
have
you,
our
sir.
support. Thank you.
Thank you. Sir, all of you can fill the attendance link which is shared in the group. Thank you. Thank you for joining the session. Next session is at 11:30. 11:30. Please join. Okay. So after completing the 11:30 to 1 session, so you'll be having at 12:55 we'll be having a photo session, and after that at 1 o'clock the test will be